everyone, welcome back to our channel, Becoming a ROS Developer here at The Construct. My name is Rodrigo, and today we have one of our students, Anderson, who has completed his course, ROS Basics, in 5 days. And then at the end of this course, there's a project with a real robot you have to complete, and this presentation is going to be showing us that project. So, hello, Anderson, how are you?
I'm very fine. Good to
Great.
see you.
Good to see you too. So yes, whenever you want, you can get started. You can share your screen and we can take a look at what you've done with your project.
Okay, so I'm sharing this screen here and share. So let me know if you can see it.
Yes, we can see the robot and a terminal.
Okay, perfect. So this is exactly the point where it should be. So I will just run my code here. Okay, perfect. I
Great.
have a ROS launch here. And what has happened? Let me see. ROS launch project 1 main launch. Launch. This is the name of my project. This. Okay, I think it was a typo.
Okay, yeah, maybe it was a miscommunication, but all right.
So first you should start searching for the wall, the closest wall. Normally it doesn't take that much. I don't know if there is a problem with my internet connection.
Uh,
I mean, I know that it takes some time, but it's taking too long.
let's see if you can see the topics of the robot. Maybe there's a problem with the connection.
Okay, here they are. I don't have command vel here.
Huh.
Yeah, command vel is not here.
Okay. So
So
it looks like
definitely
the
some.
lighter also stopped. So
You see, there is something problematic. Let me try again. Yeah, so I called the service, but it's not working. And it seems to me that
let's try and actually echo the scan, for example.
let me see. Just a second. For example, this one is the bin that I have just in front of the robot. Yeah, that's
Well,
working.
it's working, and
This is working. This is working, but oh, sorry. Now I had. I think if I try now, it will work. Let's see. Yes.
oh, there we go.
That's it. Yeah. So it was so first it starts searching for the closest wall. It found it,
Oh wow.
and then it tries to find the best posture or the stance with respect to the wall, and then it starts following the wall. It goes until it finds a corner that it has to carefully keep the wall on its right side. It goes away. So it started more or less here in the middle of this first wall.
Yeah. And what is
Okay.
that printed out on the terminal?
Yeah. Sorry. I
No,
forgot to
don't
tell
worry.
you. So here I have the measurements based on the beams of the sensor. And here
Oh,
I have the travel distance, exactly the one that is being published in the topic where I have the travel distance. So what we have here in yellow is the travel distance at this point, for example,
nice.
3.7. So let me go to the end to see. So here it's about to finish.
I like how you differentiated the two outputs with the warning message.
Yeah, so this way I
Nice.
could keep track of how much it
It
walked.
has traveled.
Yeah, so when it finished, the result is this. So all the odometry data. So I
Points,
have
yeah.
like a kind of a trajectory followed by the robot. And in here, what we have is the travel the distance that is around 6.5. So I wanted, I know that it was expected something like 6 meters, but I can show you on the code that I wanted something that goes pretty close to the wall. So
Right, right. Yeah, it will depend on how close it is. Yeah.
yeah. So yeah, so here we have the results. The same thing that I showed here, I could separate it if I echo the topic record all done where I have the feedback.
Oh,
So I
nice.
have yeah, so I have the feedback there and also the results. So
So it's an actual
uh,
topic you created?
So it's part of those topics that are automatically created once you create the action. So
Okay.
because because you create an action, so there I could subscribe to that topic and then I would see what is being published there. So in
Awesome.
the end, yeah, in the end, what I have is this. So all the trajectory followed by the robot, and then here is the status of it finished.
Well, that's really good, really smooth, and it stopped almost at the same exact location. That's
Yeah,
great. So, do you
yeah.
mind
So
just explaining us how you solved each one of these parts?
okay, so just before showing the code about
Yeah.
this thing of stopping in a good place is basically that I defined an area of it's like a square of 20 centimeter side side. So every time when it goes out, it understands that it went out, and then it goes back to this let's call home place.
I see.
It understands that it should stop. But I can show more details on the code. Let me see. The code editor is here. So this one is the main. Let's see. Let's see how it works. So this is the main files. So the main scripting file.
Uh huh.
And but before it starts running, I call the find server. So the find server, this file here, is a service. So because it has to find the closest wall and then walk to there. So here just something that I put it like additional.
Uh
I
huh.
know that it was not part of the thing, but for example, here I have something that is especially developed toward identifying or differentiating the poles. We have those obstacles in the middle
Yeah.
from a wall. So basically here I compare two beams of the sensor, and then I could define if it is a pole or if it is a wall. That what I expect to find.
Based on the distance?
Yeah, so I have like one just in front of that, and another one that is like 60 beams to the right.
Uh
And
huh.
then I know, yeah, so based on if on the measurement of that sensor, if it is higher than zero point 0.2, I know that I'm taking something that it is too thin. But if it is bigger than that, I know that I mean, the second beam is stopping close to the first one.
I
So I have
understand. Okay, so it like a continue. So it will be like a continuous value. So you know it's the wall rather than an obstacle. Oh,
rather
that's
than
great.
yeah. So later, if you want, I can do a demonstration. Like I put very very close to one of the poles, but it neglects the pole
That's awesome.
because it's interested on walls here. So the thing is that is a wall follower. And okay, so here's another thing. There's also an additional because when it starts, I know all the measurements around the robot. So I saw some other examples where the robot starts spinning and spinning, but since I knew since the beginning where is the closest obstacle, I thought that I could improve this and kind of optimize. I know that is not optimization in the strict sense of the word, but I I turned the robot to the on the direction counterclockwise or clockwise, depending on the measurement that is the closest. So I go like left or right, depending on. I don't know if you see my
Yeah, I can see you.
if you see.
Well, the audience can't, but I can see what. Yes.
Yeah, I'm gesticulating. So, okay, so this is the basic stuff. I mean, the thing that I did as additional, but here is the basic stuff where it goes to the to the wall, the closest one that it was defined, and here is where uh, I define the posture or the position that I want the robot to keep with the wall on its right
On
side.
its right. Yeah.
So, okay, so then this is typically the template of a service, and then this communicates with the main guy here, the main script.
Okay.
And then when it's finished, I call the recording of the odometry. So what I have here is basically an action. So while the first was a service that I call first, is it has this synchronous activity. So here with the action, I have something that happens while I have the main working. So the main file working. So here what I am doing is like calculating that it's pretty simple. But here what I am doing is so here's some definition, some functions, some methods of the class or some methods of the function. So here is the point where I calculate the distance. So once I calculate, I keep track of that,
Uh-huh.
putting all the values inside of this variable here that is called odoms, and at the same time I publish in the to the feedback is something that I can see later. And okay, so after doing this, what I have, maybe something that I forgot to mention is that
Uh-huh.
also in the beginning, when I find uh, a wall, sometimes I am too close to that. If I am too close, instead of going toward the wall, I
You
try
go
to
back.
step back a bit. I mean, I made a lot of tests. I did a lot of tests, but in the end, I thought that it would be better to do something more robust. So that's why I'm worried about all these different initial positions. For example, close to a pole or too close to a wall. It can
Uh-huh.
be problematic if I am too close to a wall. Maybe it's better to go back a bit and then start from there. Okay, so based on this, the last is just normal stuff. It goes it follows the wall, and I mean, there's no fancy control here, no PID, nothing related to this. It's just like keep it between zero point 0.2 and zero point 0.3 meters, and it goes until it finds the wall, and then turn left. It goes in this way until the end. And here's the normal template of calling action in the service.
Yeah.
That's it. Sorry if I talk too much.
No, no, no. That's great. So is that your whole? You talked about the service, the main program, and then the action server throughout. That's great. So first of all, Anderson, let me tell you, congratulations. Really nice and simple solution you have here.
Mhm. Thank you very
So
much.
I have a couple of questions, if you may, of things I
Please,
found really interesting. Sorry, of your
please.
project. So the first one is I want to go a little bit deeper into your obstacle detection because I always think those are really interesting. Um, so yeah, I'll keep sharing the screen. So you said
Mhm.
that you're looking at, if I understood correctly, and it's a really short piece of code, you have like 5 lines
Yes,
for this,
yes, yes,
which
yes.
I think is
Everything's
great because a lot of times people like you go above and beyond what the project asks and do something like this, you know, because the simple thing is to just start the program close to the wall. Uh, but that, of course, that would assume you're not going to be close to an obstacle because then you're going to go towards the obstacle. So you said that you're looking at 60 values. So you're looking at all of them, right?
No, no. I mean, at some
Just the
point,
first one and the
I understood that.
60th.
Yes, I at some point I understood that I don't need all of them.
Right,
So yeah, I just have to see one that is just in front of me and another one that is 60 beams away from the first from the frontal wall, frontal one. If I
right.
compare these two, it's enough. Of
It's
course,
enough, yeah, yeah.
this number is arbitrary, but with these two beams, if they have a huge difference, what do you expect? There's something thin on in front of you. But if they have similar values, what we have is probably a wall. Of course, if you put like a bunch of obstacles in front of
Yeah,
you
yeah.
and they
But
are
it's
all
not gonna
aligned,
happen, yeah.
yeah.
I understand.
But
Yeah, it's elegant, and you don't have to take into account all of those solutions of because maybe I was thinking, well, what if there was an obstacle right in front, and at the 60th there was another obstacle at
yeah,
really
so
that
yeah,
in that
probably in this case
scenario
it would think that
it's a wall.
it would think that that's a wall.
But
Yes,
it
yes,
probably would never happen. Yeah, okay, I understand. And
yes.
another scenario um, would be if you're looking at the wall at at too big of an incline, no? Because maybe then that point two would be like point four, and then or whatever
Yeah,
lesser
but
or
this value is something that I could adjust in
yeah.
the code. And
Okay.
now that you guys you changed the kind of poll, is even easier to do it because I mean, just last week,
Yeah.
the poll was a kind of triangle.
Yeah, it
It
was a
was
foam triangle.
a
Yeah.
prismatic. But now it's even easier because now it's just a very thin poll that I can
It's like
differentiate.
one value. Yeah. Yeah.
Yes, yes.
Okay. Yeah.
So
Well, I
that's it.
love that solution. I love it. It's very simple,
Hmm.
because sometimes people really, I mean, it's great. It's an awesome way of doing it. Really spend time here and then put it filters and a whole program for it when you
Yeah,
can
yeah,
just
exactly.
solve it with that much. You know, I love that.
Yeah.
I love it. Um, and then the other question I had is that you
Mhm.
talked about how you included a scenario in which when you're finding the wall, you're too close to it and then you step back. So I wanted to
Yeah.
ask you, what do you think the reason would be for you to end up too close to the wall?
I mean, I know that this is not part of the regular scenario, let's say, that we should present here, but I mean, during my tests, sometimes I didn't know what is the spinning associated to some amount of angular rotation that I defined there. So I defined a number, but I didn't know how much it would turn in the end.
Uh-huh.
So when I tested this, I start from a random position. It started from a random position. So what it happens is that from time to time, unfortunately, I'm sorry for saying this, but I hit the wall with
Oh, don't
the.
worry. Yeah. Okay.
So I know that it's pretty robust and it's able to do it. But the case is that it was perfectly working if I start a bit away from the wall. But sometimes, from time to time, it happened that I was too close, and I hadn't time enough to turn the robot until it finds a position where it can pursue its task
The
without
wall.
colliding with anything. So because of this kind of initial position, I thought that maybe it would be better in this on these cases. I can show you demonstrate, but the general idea is that if I am too close to a wall, it's not the ordinary. I repeat, it's not the ordinary scenario. But if I am too close to an obstacle, it will understand that you don't have a space. You know, when you drive a car, you know that if you are too close to a wall, maybe it's better if you go back first and then you have space
Yeah.
enough to turn and then start your movement.
All right.
That's the
Okay.
the idea.
Great. Do you mind stopping sharing your screen so we
Ah,
can
sorry,
uh,
sorry, because I'm gesticulating.
yeah,
So
finish up? No, don't worry, don't worry. So awesome. Another thing I wanted to mention. Maybe it's a reason why you were saying you don't have enough time to once you reach the wall. That maybe can be solved with the rate at which you spin the node, and that's the ROSB rate. So maybe at a
all right.
faster rate, it could maybe solve some of that issue with you for that. But I like the solution you implemented. Um,
So I could also increase the angular velocity depending on the distance of the wall. This is also something that I think in one of my drafts I implemented this, but I thought that this way was more elegant. It had like a third functionality,
yeah,
so it had the regular functionality, but also this thing that smartly understand that it is too close and then goes back and without changing any velocity. The velocity I also I saw in the notebook that it was said that if overcomes a threshold of velocity, it could suddenly stop. So I was
yeah,
afraid of that. So I didn't want to change the velocity accordingly to something. I kept the velocity at some point that I was confident it would work from the beginning to the end, and then I just played with other variables.
yeah. That's a safety measure we added in case people, send a really quick velocity that might cause the robot's top to fall or something, because
No,
it's
makes sense.
connected.
No, makes sense.
So we just have that. All right. Well, then, other than that, Anderson, I think that was a great presentation. So again, congratulations, and we're we're excited to see more of your projects in the future, and we hope
Okay,
you took something out of this course.
amazing. Yeah, so it was very nice. A very nice course. Thank
All
you very
right.
much, Rodrigo.
Okay,
Thank you very
then.
much.
For everyone else that's watching, this is what you can do when you take our courses for ROS. You can then show what you've learned and actually show it with a real robot. So I encourage everyone to do what Anderson did here, and yeah, that's it for all of us. Thank you again very very much, Anderson, and we'll see you next time.
Okay, see you.
All right,
Thanks.
bye bye.
Bye. Bye.